product. Udu honuma coffee at the biafra. Ah, coffee in a gum. Minimo. Ah, where in Suana alcohol, minimo. You can probably check specific gravity. Just that simple. Use this apparatus, this specific gravity bottle, the picnometer. Very simple. We share in mark and at a certain mark. You check the weight of the sample first. Yes. Go ahead.
With that bit, I wanted to know: is it when it's purely alcohol that the viscosity, the specific gravity is going to be less than one, or when it's a mixture of water and alcohol, you still have the specific gravity less than?
All right. So once there's alcohol in there, it would change it from one. So obviously, the more alcohol it is, the lesser it's coming down from the one. So it will indicate it. So I was saying how you do it. So if fill a bottle now, the one check it to us. If you check the weight, you fill it, and then you do a calculation and know the weight of your substance, of your product, and then you do the same for water. Then you find the ratio. That's quite simple, and it will give you your SG. Simple, sir. You. So another physical method is the moisture content. This is very important. And this one is not just for the product. This one goes even to the plant material. And I think most of us should always check this for our plant material. Even before we store, you should try and check the moisture content before you even store your. So it come about is the amount of water, basically amount of water content and water in your plant material or your product. And basically it is usually for not usually, it is for solid dosage forms or something that is solid, not liquid. You can't heat. I mean, you can't check water the way we use it, we do it. Ultimately, we use water. Unless you fish, of course, unless you fish dry and then come and check. In that case, it doesn't make sense. Why will you fish dry product and then come and check water content? Usually for solid dosage forms, it's what you use. We check the moisture content or plant material. You can check the moisture content using this machine. So basically, the moisture analyzer, you put your sample in there, you heat it at this temperature to a constant weight. You heat such a way that at a point the temperature in the weight in the sample. So it will show maybe at 2 grams. We heat about maybe 1.5, 1.3, 1.7, up to 0.8 after Nkobio. When it's not changing for a number of a period of time, that's a constant weight. It means we assume all the water is out. That's constant weight. And then you note that weight. And then you do a calculation, as I've stated there, and that will give you a moisture content. In so do na a womb. Because there was no in so womb, not the share machine room. Now machine we actually so near film. Until me say me who say na wait net here before I'm shame. I feel a chin so in film no. Wait na I say. Into difference no. In so do na a war plant material drag no. Now mind you, it is important because when there's usually when there's a lot of water, there's a lot of microbial activity. With those them, the more water content in there, the easier it decays or gets spoiled, or microbes can grow in them. So usually we try to reduce your moisture content as much as possible. Inside make I say, Anka, anytime you want to store your product, make sure say what hatani ye. And I watch check. In fact, what checking moisture content and who say is very, very minimal. Right? And then you can put it. I think those who came the previous training that you had, those who did the plant cultivation, those things, I'm sure they mentioned the moisture content thing to you, the level that you need to keep to. Yeah, but basically, you should make sure that moisture content is very low using that. And then the next one will be our ash value. Ash value, where we use this incinerator. See, basically, what this one means is that sometimes we expect that your plant or your product, so you are doing herbal medicine, and it should be organic. They are natural and organic. When if you remember your chemistry, organic is basically carbons. They're basically carbons, right? And carbons burn, but the minerals, like the elements, like the phosphorus and the likes, they hardly burn. So you're expecting that if indeed I have only plant material in there, then it should have burnt. Everything should burn to ashes. So you're going to burn your product or your plant material, of course, once again, the sausage, solid dosage form or plant material. You burn it to ash. You burn totally to ash. And after that, you will check the amount of it. Now, if everything burns out, you will know. If it doesn't burn, if you have phosphate, so if you have phosphate, carbonate, and silicate in there, it will make it go high. But those ones it won't burn. So you want to basically check for the presence of these ones after burning. That's basically ash content. Yeah. But the solvent you use, you can probably dissolve it in acid or sometimes in water, which is why we give the different methods that we write: acid, insoluble ash, or water soluble ash. Sometimes you just burn it and check weight, which is what we call the total ash. But other times you burn and after it dissolve and see how much of it will dissolve. If everything dissolves, it means you probably don't have phosphates and carbonate and silicates in there. That's basically what we do for ash. And there's the machine in there is what you use. The furnace. It's a furnace. Unfortunately, center soon broke down. I expect that they will fix it or buy another one soon. But I think you can easily get this. Then these ones are optical rotation. Usually, I think we use this for. I'm not sure any herbal medicine people will do this, but yeah, the orthodox medicine they do, because okay, so for what I trained, because it's more of synthetic things we're doing, so we usually did this. When you do the polarizer, right? For a compound, you remember who answered that question? I think there was this. The one we're looking at the two structures, a rotation around, like the S, R, and S and those things I have. Now, depending on how the carbons are arranged, the elements are arranged around the carbon, for example, they will polarize light differently, right? So if you put your compound in the path of light, which is stated, the light, this is the sodium light. If you put it in front of light, now it has 4 different groups arranged differently on it. It will polarize differently from if you have, for example, if you have 2 groups or 2 groups that are the same but on the same carbon, it will polarize light differently. So I can tell if what my compound is or what my drug is pure or not pure. That's the adulterations I will know using the optical rotation. So for example, they've stated that of castor oil. They know that castor oil will have this optical density between this range all the time. Into some my media, that's my established say anytime I do castor oil, I have castor oil in my product, I should have this result. Once I don't get it, it means your product does not contain castor oil. You understand? So that's one thing.